On the 22nd of July, 2026, the chief executive of Alphabet told investors that one team inside Chrome was on track to accelerate delivery by 8 times. A 2-year timeline compressed into 3 months through model-driven refactoring. Those are the words on the page. 4 weeks later, the head of data at a project tracking company called Linear published 6 years of telemetry on how software actually gets built. 127,000 paying users, 47,900 workspaces. Teams that connected a coding agent went from 21 pull requests a week to 65. And then, in the closing paragraph this, we have no way of knowing whether this increased output led to positive business outcomes. Here is my thesis, and I want to state it before I defend it. We are losing the ability to measure whether artificial intelligence makes software engineering faster at precisely the moment the claims about it are getting larger. Not because anyone is lying. Because the one experiment that could settle it has stopped working, the surveys measure what people feel, and the only thing left that counts cleanly is the number of artifacts opened, which is the exact quantity these tools are built to inflate. That is not a conspiracy. It is a measurement failure, and the people closest to the data are the ones saying so in footnotes nobody reads. Chapter 1: The Number That Traveled. Linear is a project tracker. Engineers file issues in it, attach pull requests to it, and close them out. It is unglamorous software, and that is exactly why the report is interesting. The company can see the whole shape of a working week, from the first ticket to the code change that closes it. This month they published edition 1 of something called How Teams Build. The author is Tim Chi, their head of data, and the numbers run through the first week of August. On the 18th of August, 2026, it reached the front page of Hacker News. The headline finding is a single chart. Take the teams that connected a coding agent to their workspace and follow them from June 2024 to June 2026. They opened 21 pull requests a week at the start. They opened 65 at the end. Now take the teams that never connected 8 a week at the start, 10 at the end. I want to be fair to this chart because it is better built than most of what gets published on this subject. It is a fixed cohort, 6,887 paid teams, 4,280 of them with a coding agent, 2,607 without. The same teams tracked across 2 years. So the tripling is not an artifact of new customers arriving. And Linear says plainly that the agent teams were already shipping more before agents existed, so the levels are not comparable, only each cohort against its own baseline. Across all 47,900 paid workspaces, pull requests per team per week are up 111% against a June 2024 baseline, flat for the first year. Then it bends upward through 2026. The adoption numbers are just as sharp. Between January and June of this year, the share of users active on Linear's own artificial intelligence features more than doubled in every job function. Engineering went from 12% to 30%. Product went from 12% to 34%. And chief executives at companies of 201 people or more went from 9% to 36%, the largest jump of any cut in the report. Product managers attaching pull requests went from 3% to 10% in 2 years. Designers went from 1% to 8%. The people who used to describe a change are now shipping it. There is one more chart, and it is the one I keep coming back to. Issues created per week split by who created them. In June 2024, agents and machine clients created fewer than 1 issue in 1,000, essentially 0. By the first week of August 2026, agents were creating 2,435,000 issues a week, against 2,481,000 from people and integrations. Agents are within 2% of authoring more of the work than humans do. Read that again because it is easy to hear it as a productivity statistic, and it is not one. It is a statistic about who is filling in the tracker. The tracker is the instrument, and the instrument is now being written to at scale by the thing it was built to observe. So an enormous, carefully constructed dataset showing that output tripled where the agents are, and that the machines have nearly taken over the paperwork. That is the sentence that traveled. Now read the last page. Chapter 2, the closing note. Every report of this kind has a methodology appendix that nobody reads. Linear's is unusual because the most important sentence in the entire document is not in the appendix. It is in the closing note, signed by the head of data, and it dismantles the headline. Here is the definition first because it does most of the work. Quote, pull request, a code change opened against a repository connected to Linear, We count pull requests opened, not merged, end quote. Opened, not merged. A pull request that was opened, reviewed, argued about, and closed unmerged counts exactly the same as one that shipped. So does a pull request that was opened 3 times because the agent got it wrong twice? Linear says this itself in the chart caption, quote, "An open PR says nothing about the value of the change, but the inflection is hard to miss." End quote. Then the closing note, quote, "We have no way of knowing whether this increased output led to positive business outcomes, but it shows a very clear correlation between AI adoption and acceleration." End quote. And then the paragraph I think is the actual finding of the report, and which I have not seen quoted anywhere. Quote, "Those gains haven't shown up as time saved though. Time spent on existing tasks in Linear held while AI usage appeared as a new layer of work, meaning the overall time spent on product development is going up rather than down. As far as we can observe, teams are working more, not less." End quote. Sit with that. In the same dataset that shows output tripling, time spent went up. Engineering create and triage time rose from 24 minutes a month to 28. Engineering commenting rose from 35 to 40. Founders commenting time rose from 39 minutes a month to 64. And 2 entirely new categories appeared: chatting with the model and delegating issues to agents. That did not exist a year earlier. Linear's own summary of that, quote, "Nothing else shrank to make room," which suggests AI has landed on top of existing work rather than replacing any of it, at least so far. End quote. One more caveat, and it matters for how far you can push any of this. Linear can only see what happens inside Linear. Their own opening says it. What we can't see is AI usage that happens outside Linear, so this is a picture of adoption inside our own customer base, not the market at large. And pull requests only count if the repository is wired up to the tracker. Every number in this report is a floor, taken from a self-selected population of companies that chose to buy a modern project tracker. That cuts both ways, and you should hold it in mind in both directions. They have a name for it. Jevons paradox, the 19th century observation that making a resource cheaper to use increases rather than decreases the total consumed. Coal in the original, coordination here. And finally, the concession that most authors would have buried. Quote, "Many will rightfully argue that looking at pull requests indicates motion rather than value, which is certainly true, but it's still a step forward from measuring tokens." End quote. That is an honest researcher describing the limits of their own instrument. They are right that counting pull requests beats counting tokens. They are also telling you, in plain words, that what they measured was motion. The question is what happened to that sentence on its way out the door. Chapter 3: What the Room Said. The report hit the front page of Hacker News on the 18th of August. 176 points and 110 comments, though only 62 of those come back through the public interface, the rest being flagged or dead. I read the 62 and I want to be careful about what that is worth, because this is where this kind of story usually goes wrong. Everyone in that thread is a pseudonym. I cannot verify that any of them are engineers or where they work, and neither can you. 1,000 upvotes is not evidence. What a comment thread is good for is telling you which claim the practitioners in the room refuse to swallow, and why, and then you go and check the why somewhere else. Here is what they refuse to swallow. The top comment from a user posting as JDW64 is one line. Quote, "These days my work has become generate code for 20 minutes then spend an hour reading it." End quote. Underneath it, a reply from someone posting as whatever act. Quote, "I spend 45 minutes writing it. Then I get commit and move on because I made something good. Who is winning here?" End quote. A user called GreatJib raised the obvious methodological objection that Linear is measuring pull requests it can detect, and detection depends on teams wiring up their repositories correctly, so growth in the number might just be growth in the plumbing. That is a good instinct, and I want to correct it because it does not survive contact with the document. The coding agent chart is a fixed cohort, the same 6,887 teams throughout, and the volume chart is measured per workspace, not in total. Both of those defenses are in the report. This is the part of the exercise people skip. The thread was right to be suspicious and wrong on the specifics. The sharpest comment came from a user posting as well_actually, and it is not an anti-AI comment at all. Quote, "Doubling pull request isn't necessarily unbelievable. AI reduces ceremony around PRs, makes the small shitty changes that you never had time to do possible, and the larger cleanups at least doable. Double the PRs doesn't mean double the output." End quote. That is the whole argument in 4 sentences, and it is a friendly one. If a tool lowers the cost of opening a change, you will get more changes. Some of them will be things that genuinely needed doing and never got done. That is a real gain. It is also mechanically an increase in the count that is independent of how much value was created. Another user, GCamel, put it more bluntly. This looks like measuring what is easy to do rather than what really matters. And the thread was not one-sided. A commenter called Lukibits described leaving an agent running for 3 hours against a genuine bug in the Godot game engine, where particles spawn beneath a collision box, and coming back to a working fix with continuous collision detection. They also wrote that they had not upstreamed it, because they were sure someone would find something to complain about in the code. That is the most honest description of the current state of the art I read all week. One more from a user posting as Clinton, who said their own company uses the product. Quote, "The data presented in this blog post is worthless to me and the company. It can be crudely summarized as agents and agentic development processes are conducting more linear operations." End quote. That is uncharitable, and I think it is also roughly correct. None of this is evidence, it is anecdote on both sides, so where is the experiment? Chapter 4, The Experiment That Worked. There is exactly one properly randomized trial of frontier coding tools on real work that I know of, and it is worth walking through slowly, because almost everything you have heard about it is a compressed version. In July 2025, a research organization called METR published a paper titled Measuring the Impact of Early 2025 AI on Experienced Open-Source Developer Productivity. The authors are Joel Becker, Nate Rush, Elizabeth Barnes, and David Rain. The design is the point. 16 developers, 246 real tasks in mature open-source projects on which those developers had on average 5 years of prior experience. Not a benchmark, not a toy repository. Their own code that they already knew. Each task was randomly assigned to allow or to disallow AI tools. When allowed, the developers mostly used Cursor Pro with Claude 3.5 and 3.7 Sonnet, the February to June 2025 frontier. Now the numbers in the order they happened, because the order is what makes this study famous. Before starting, the developers forecast that being allowed to use AI would cut their completion time by 24%. Outside experts were asked too. Economists predicted tasks would take 39% less time. Machine learning researchers predicted 38% less. After finishing the study, after doing the work with the stopwatch running, the developers estimated that AI had cut their completion time by 20%. The measured result was that allowing AI increased completion time by 19%. The confidence interval runs from 2% to 39% longer. So they were slower, and they believed they were faster, by a margin of nearly 40 percentage points. That gap between felt speed and clock speed is the single most important result in this entire field, and it is why I do not accept anybody's self-report as evidence, including my own. Now the fairness section, because this study is routinely used to prove things it does not prove. The authors wrote out their own non-claims, and I will honor them. They do not claim that AI fails to speed up most developers. 16 people is 16 people. They do not claim it holds outside software. They do not claim future tools will behave the same way. They say progress is hard to predict. And they explicitly allow that there may be better ways to use these tools than their participants found. They also identified why the slowdown happened, and it is mundane. Context switching to and from the tool, debugging what it produced, integrating it, learning it, and meeting the quality and documentation standards those projects demanded, which the model did not meet on its own. I want to dwell on one of those because it recurs everywhere in this story. The developers had to meet a standard. Open-source maintainers of mature projects have opinions about naming, about test coverage, about whether a fix addresses the cause or the symptom. The tool produced code that ran. Getting it to the point where a maintainer would accept it was the expensive part, and it was not counted anywhere except on the clock. Hold that thought, because a pull request that is opened and never merged is exactly the shape of that failure, and it is counted as a success by the metric we met in Chapter 1. So the honest summary is narrow. On mature code bases they knew intimately, with early 2025 tooling, 16 experienced developers got slower and could not tell. The obvious objection is the correct one, that was early 2025. The tools have changed enormously, so METR ran it again. And that is where this story stops being about software and starts being about measurement itself. Chapter 5: The Experiment That Broke. On the 24th of February, 2026, METR published a follow-up. The title tells you the ending before you start reading it. We are changing our developer productivity experiment design. They had launched a second study in August 2025. 10 developers carried over from the original, plus 47 newly recruited from a wider set of open-source projects. Same protocol. Pre-specify the task, submit it for randomization, get told whether you may use AI, record how long it took. One change worth flagging: they cut the pay from $150 an hour to $50. The raw result flipped. For the subset of original developers, METR now estimates a speedup of 18%. For the newly recruited developers, 4%. If I stopped there, you would have the headline: 19% slower in early 2025, 18% faster in early 2026. A complete reversal. The tools caught up. Do not stop there. The confidence interval on that 18% runs from 38% faster to 9% slower. It crosses zero. The interval on the 4% runs from 15% faster to 9% slower. That also crosses zero. Neither result is statistically distinguishable from no effect at all. And then METR says something that research organizations very rarely say about their own data. Quote, "Given participant feedback and surveys, we believe that the data from our new experiment gives us an unreliable signal of the current productivity effect of AI tools." End quote. Why? Because the control group is disappearing. Quote, "We have observed a significant increase in developers choosing not to participate in the study because they do not wish to work without AI." End quote. And worse, among those who did participate, quote, "When surveyed, 30 to 50% of developers told us that they were choosing not to submit some tasks because they did not want to do them without AI." End quote. Think about what that does to the arithmetic. If a developer looks at a task, judges that the machine could do it in 2 hours where they would need 20, and quietly declines to enter it into a study that might forbid them the machine, then the study systematically never sees the tasks where AI helps most. One participant said exactly that in those words. Another put it like this, quote, "My head's going to explode if I try to do too much the old-fashioned way, because it's like trying to get across the city walking when all of a sudden I was more used to taking an Uber." End quote. METR's own verdict on their central estimate, quote, "These issues make it challenging to interpret our central estimate, and we believe it is likely a bad proxy for the real productivity impact of AI tools." End quote. Now here is where I have to be scrupulous because it would be easy to weaponize this. METR believe developers probably are faster now. They say so. Based on conversations with study participants, they think it likely that developers are more sped up in early 2026 than in early 2025. But they are explicit that this belief comes from conversations, not from the experiment, and that their data is only very weak evidence for the size of it. The randomized controlled trial, the one instrument that could settle this question, has been defeated by adoption. You cannot run a control arm when the control arm walks out. Chapter 6: A 37-point swing. So we have a study that says, in effect, do not quote our number. What happened next is the thing this whole video is really about, and I found it by accident. On the 10th of July, 2026, an industry write-up appeared, surveying what the productivity research actually found. On METR, it says this. Quote, "By early 2026, METR revisited a subset of that same developer cohort and now estimates a speedup of roughly 18%, confidence interval -38% to +9%, so the uncertainty band is still wide." End quote. Credit where it is owed, they printed the interval, most write-ups do not. Then the next sentence, quote, "That's a 37 percentage point swing in a single year, and METR's own explanation is straightforward: the tools got better and, more importantly, the developers learned how to use them." End quote. That is not METR's explanation. METR's stated explanation is selection bias. It is in the post at length with survey percentages attached. The word METR uses about their own estimate is unreliable. The phrase they use is bad proxy. Nowhere in that post do they attribute the change to tools getting better and developers learning. They attribute it to the fact that the developers who most benefit from AI stopped showing up, and the tasks where AI helps most stopped being submitted. I do not think this was malice, and I am not going to name the author because the point is not that one person got it wrong. I think somebody read a long-hedged technical post, extracted the two numbers, computed the difference, and reached for the most natural story that connects them. That story is plausible. It may even be true. It is just not what the study said, and the study is now being cited as its source. This is the load-bearing failure mode of the entire discourse, and once you see it everywhere. Here is a second instance from the same week. Search for the Stack Overflow Developer Survey and you will find a run of 2026 write-ups reporting a 2026 survey. 84% of developers now use AI tools, only 3% highly trust the output, 49,000 respondents. Striking numbers. I went to Stack Overflow's own survey site to read the source. Those are the 2025 figures. As of today, the 20th of August, 2026, Stack Overflow's survey site still lists 2025 as its most recently published edition. The numbers are real, 84% using or planning to use AI tools, up from 76. 46% actively distrusting the accuracy of the output against 33% trusting it, 3.1% highly trusting it. Among developers with 10 years or more experience, 2.6% highly trust it and 20% highly distrust it. All accurate, all from last year wearing this year's date. A stale number is more dangerous than a wrong one, because a wrong number gets challenged and a stale one just gets older. And notice which direction both errors run. The me citation upgrades a disowned estimate into a finding. The date drift makes a year-old adoption figure current. Nobody is inventing anything. The distortion is entirely in the compression, and compression structurally keeps the striking number and drops the interval. Which brings us to the largest study of the lot, and what it found when it looked past the headline. Chapter 7, Second Place. Dora is Google Cloud's long-running research program into software delivery, 11 years of it. Their 2025 edition is titled The State of AI-Assisted Software Development, and it draws on more than 100 hours of qualitative interviews plus a global survey of nearly 5,000 technology professionals, conducted between the 13th of June and the 21st of July, 2025. Note that date, it is over a year old. That matters and I will come back to it. The headline findings are the ones you have probably absorbed. 90% of respondents use AI as part of their work. More than 80% believe it has increased their productivity. And a notable portion, 30%, report little to no trust in the code it generates. The framing DORA chose is that AI is an amplifier. It magnifies the strengths of high-performing organizations and the dysfunctions of struggling ones. That is a good line, and I think it is broadly right. But there is a chart in the executive summary that I have never once seen reproduced, and it is the most interesting thing in the document. It ranks the outcomes associated with higher AI adoption by the size of the estimated effect. Here is the order. First, individual effectiveness, how effective a person reports feeling. Second, software delivery instability. Then organizational performance. Then the percentage of time spent on valuable work. Then code quality. Then product performance. And only then, in seventh place, software delivery throughput. Instability is second, throughput is seventh. And instability in DORA's framework is not a vibe. It is two hard measures. Change fail rate, the proportion of deployments that require immediate intervention, and rework rate, the proportion of unplanned deployments that happen because something broke in production. DORA's own summary sentence is this, quote, AI adoption now improves software delivery throughput, a key shift from last year, however it still increases delivery instability, end quote. Now the fairness, and it is substantial. DORA also finds code quality positively associated with AI adoption. Team performance 2, organizational performance 2, this is not a report saying AI does not work. And critically, every one of these is a self-reported survey measure from a single point in time, which is why endnote 20 of that report reads as follows. Quote, last year we spoke in terms of effects. This year, however, we will speak in terms of comparisons. Although we try to do the work to create the conditions to speak causally, we don't want to give false assurances that we understand the underlying causal structure. Occasionally we will speak in causal terms, but ultimately we're doing comparisons. End quote. That is a research team quietly retracting the word effect from its own vocabulary in a numbered endnote at the back of a long report. Nobody quotes endnote 20. And one voice from their interviews, an anonymous practitioner, describing what all this feels like from inside. Quote, stakeholders are expecting more work to be done in a quicker manner. So deadlines and projects are on a shorter time crunch, and it's definitely changing the way I work. So that worries me a little." End quote. That is Linear's Jevons paradox, said out loud by someone living in it. The tool made the work cheaper. The expectation absorbed the difference immediately. Chapter 8 on track. Let us go back to where we started and read the sentence properly. 22nd of July 2026. Alphabet's second quarter earnings remarks published on Google's own blog under the chief executive's name. Quote, "Anti-gravity is a powerful tool for users and enterprises, and it's completely accelerated how we build internally." As just one example, a team in Chrome is now on track to accelerate delivery by 8 times, compressing a 2-year timeline into 3 months through model-driven refactoring. End quote. Now 3 observations, and none of them require assuming anyone is being dishonest. 1. On track to, that is a forecast, not a result. The 3 months have not elapsed at the point the sentence is spoken. It is a projection of an 8 times acceleration delivered to investors, and it is grammatically careful about that in a way the retelling will not be. 2. A team in Chrome. One team selected by the company from a company with tens of thousands of engineers. Chosen precisely because it is the best example available. That is what just one example means when a chief executive says it. It means this is the one we are showing you. 3. I have looked and I can find no published verification of that figure. No methodology, no baseline, no definition of delivery. It may well be entirely true. There is simply nothing to check. Compare the shape of that to April 2025, when Microsoft's chief executive told a Meta developer conference that 20 to 30% of the code in Microsoft's repositories was written by software, with better results in Python than in C++. That figure is now 16 months old and still circulating as current. And the reporter who broke it wrote in the same article that it was unclear how Microsoft and Google were measuring what counts as AI generated, so the figures were best taken with a grain of salt. That caveat did not travel. The number did. Now let me tell you what I actually think, because I have spent this whole video being careful and you are entitled to a position. I think the tools work. I use them. I think the Godot particle fix in Chapter 3 is real. I think METR are probably right that developers are faster in 2026 than they were in 2025. And I think Linear's tripling is a genuine measurement of a genuine change. What I do not think is that anybody currently knows what it is worth. Every number in this video is either a count of artifacts opened, a self-report, or a forecast. The one design that could have told us something harder has been broken by its own subjects refusing to give up the tool. That asymmetry is the whole problem. A claim is cheap to make and travels intact. A measurement is expensive, arrives hedged, and loses its hedges in the first retelling. So the public numbers get bolder a share of the code than a multiple of the whole delivery timeline, while the evidentiary base underneath them gets thinner, not thicker. So what would change my mind? Linear says the next edition will trace the full life cycle from tokens spent to outcomes, now that code review runs through their product too. If they publish agent-driven pull requests split by merged, reverted, and abandoned, and the tripling survives, I will drop this argument entirely. That is the single most useful chart anyone could publish this year, and they are the ones who can. Second, a high-compliance experiment. METR named the fix themselves shorter, more intensive studies at higher pay so the control arm stops walking out. If that returns a clean speedup with an interval that does not cross 0, the measurement crisis is over and I was wrong to call it one. Third, Alphabet could publish the Chrome numbers. Baseline, definition, and the result once the 3 months are up. One team, fully specified, would be worth more than every survey in this video. And here is what would confirm the pessimistic reading instead. If DORA's next edition still has delivery instability ranked above throughput, if the second largest thing associated with AI adoption is still that a software organization's deployments fail more often, then the artifact count was never measuring what we hoped, and we spent 2 years congratulating ourselves on motion. The evidence for that is not in yet. That is precisely my complaint.